All right, today we're diving into a real cosmic detective story. We're on the case of 3I/Atlas, only the third interstellar visitor we've ever spotted. And this thing, well, it had this bizarre split personality that completely stumped scientists. So let's start piecing together the clues. And that's really the heart of the mystery, isn't it? How can one object be two completely different things at once? On one hand, 3I/Atlas acted like this calm, predictable giant. And on the other, it was like a wild, powerful rocket. The switch from one to the other was sudden, violent, and the timing was, well, perfect. So which one was it really? For months, as this thing was cruising towards the sun, it was rock solid, predictable. But the second it hit perihelion, its closest approach, bam! It just violently lurched off course. And we're not talking about a little nudge here. This was a huge shove. To figure this out, we've got to look at the case file in two parts. So first up, the case for the giant. Because the first clues, all the early evidence, pointed to an object of just impossible size. It basically backed scientists into a corner, forcing them to accept a conclusion that, statistically speaking, just shouldn't be happening. Okay, so this is where it gets really weird. Astronomers took thousands of measurements and, yeah, it was clearly acting like a comet. It had a coma, that classic fuzzy cloud of gas around it, so it was definitely shedding material, but here's the kicker. Even though it was spitting out all this gas, its path was perfect. Like it was only following the pull of gravity. It wasn't getting pushed around at all. Now that push has a name. It's called non-gravitational acceleration, or NGA for short. Just think of it like a really small rocket engine on the comet. As the ice on its surface heats up and turns to gas, it jets out, and that pushes the comet just a little bit. It's the classic signature of an active comet. And for months, 3I/Atlas showed absolutely zero NGA. Nothing. So you see the paradox, right? You've got an object that is clearly firing its engines. We can see the exhaust, but it isn't moving an inch off its gravitational path. How is that even possible? Well, there was really only one logical explanation that could fit the data. The rocket effect was there, all right? The object itself was just too massive to be budged. And when they crunched the numbers, wow. They came up with a minimum mass of 33 billion tons. That means you're looking at a solid nucleus at least 5 kilometers across. To put that in perspective, that's roughly the size of Manhattan. For an interstellar visitor, that is just mind-bogglingly huge. And just to give you a sense of scale, let's look at our other interstellar guests, Oumuamua and Borisov. 3I/Atlas wasn't just bigger, it was between 1,000 and 100,000 times more massive. I mean, it's not even in the same league. Finding something this big, this early in our search was a huge statistical red flag. It completely upended what we thought we know. So the case seemed pretty open and shut, right? 3I/Atlas was this impossibly massive, super stable giant. But then it got a little too close to the sun, and that entire beautiful theory just got blown to smithereens. Check out this timeline of the event. For months, totally stable flight, no NGA. Then, on October 29th, 2025, the exact day it made its closest approach to the sun, it suddenly jumped. It shifted 4 arcseconds off its predicted path. Now, from our viewpoint on Earth, that is a massive leap. It was a clear sign that some powerful new force had just kicked in. And the data just shows how violent this change really was. Before this moment, its acceleration was less than 15 meters per day squared. That's basically zero. We couldn't even detect it. Then, in an instant, it jumped to 135 kilometers per day squared. That's like going from a standstill to firing a full-blown rocket engine. The stable giant was gone. So what on earth happened? Well, the key to solving this mystery wasn't in its trajectory anymore. It was in its exhaust. The solution was hiding in the chemical soup of that gas cloud that was surrounding the object. Using the James Webb Space Telescope, scientists took a closer look and found the coma was packed with carbon dioxide. Now, unlike water ice, CO2 turns to gas at way colder temperatures. It's basically a hyper-volatile fuel. So 3I/Atlas was carrying around this massive tank of high-octane rocket fuel, just waiting for a match to be lit. But that's not even the weirdest part. They also found atoms of nickel and iron in that cold gas cloud. And that shouldn't happen. It's just too cold for those metals to vaporize. the leading theory is pretty wild. These metals were being ferried out by some kind of exotic compound, maybe something called nickel tetracarbonyl. That's a substance we actually use in industrial processes here on Earth. This was definitely no ordinary comet. And this one idea pulls everything together. The theory goes that as 3I Atlas got closer and closer to the sun, the heat finally became intense enough to crack through a protective outer crust. And when that crust broke, it suddenly exposed this massive hidden reservoir of that super volatile CO2. The spark had finally hit the fuel tank. So it seems like we've solved the case of the object's bizarre movement. But, like any good detective story, closing one case just opens up another, even bigger one, putting 3I/Atlas right in the middle of a much larger puzzle. So here's the final theory, step by step. First, you have this massive object with a protected core full of fuel flying toward the sun. Second, at its closest point, the sun's energy cracks the shell. Third, you get this catastrophic, sudden release of CO2 and all those exotic gases, creating a ridiculously powerful rocket effect. And fourth, the blast was so intense that the object might have lost up to a sixth of its entire mass in just 1 month to generate that push. And this is why 3I/Atlas is such a big deal, because its behavior, once we figured it out, kind of gives us a baseline for what a normal interstellar comet should look like. And that, in turn, makes our very first visitor, Oumuamua, even weirder. See, Oumuamua accelerated too, but it did it with no visible gas cloud, no exhaust. So now we basically have two totally different classes of interstellar visitors, one that acts like a comet we can explain, and another one that still has us completely stumped. But, the case file on 3I/Atlas isn't completely closed. I mean, was that first giant mass estimate just flat out wrong? What's the deal with its bizarre nickel chemistry? And why did it have this super rare 1 in 500 alignment with our solar system? Was that just luck? Could this thing actually be an ancient relic from the cosmic noon, a time when the universe was young? These are all questions we still don't have answers for. In the end, 3I/ATLS really leaves you wondering, are these strange visitors just cosmic flukes, incredible coincidences, or are they clues to something much, much bigger? For every mystery we think we solve out there, it feels like there are countless others, just flying silently through the dark.
If you're ready to explore the hidden truths behind mysterious sciences, subscribe now and become part of the enlightened society.